Our presenter today is Jeff Tao, the founder and CEO of TDengine. Jeff has an extensive background as a technologist and serial entrepreneur with more than 20 years of experience in software development. As the CEO and founder of TDengine and Jeff has been leading a team of talented developers and engineers to deliver simplified and scalable solutions for time series data processing. So, kicking off to you, Jeff.
Hello, everybody. Thanks, Sona. Hello, everybody. My name is Jeff Tao. It's my honor to give a presentation about what we are doing. My topic is about next generation historian. Today, I'm going to talk about a few things. When we talk about the next generation, of course, there is a traditional one. I'm going to talk about the good things and the bad things about the traditional data historians. Then we are talking about our new approach and also talking about the competitive advantages. And also at the last, I'll talk about the case study. Okay, so let's start. So data historians are widely used. There's so many data historians on the market. There are more than 40 years history for data historians. Okay, like OSI Soft, AspenTech, Honeywell, or Wonderware, they all works very good. Actually, those traditional data historians prove to work well for a single site. And I never heard about complaints aside from the cost. The only complaint I heard about those traditional historians is just price. Okay, everything those Pi system or AspenTech or Wonderware works pretty good, but the world is changed, right? There's still something not good for traditional data historian. Like for example, low horizontal scaling, but now with the growth of IoT devices, the data volume is getting bigger and bigger. If you don't have a scalable solution, it's hard to meet the business demands. That's number one. Number two, the traditional data historian doesn't have a very good data analytics functions. Most of them don't support standard SQL. So the analytical functions are very limited. Number three is those traditional data historians are always closed ecosystem. So those manufacturers are always locked by those vendors. You know, not that open. I'm not saying they are not 100% open, but it's not that open compared with those modern softwares. Okay. Another one thing is the pricing is based on number of types. The traditional business model, they always charge based on number of types. If you have more types, you want to charge more. But think about it now, there's so many types. Okay, because there's so many devices that are internet connected. So then sometimes you need to pay over a few million US dollars if you use a traditional data historian. Okay, then it's very hard to be accepted. Last thing is now everything is moved to cloud application, or even the data historian should be cloud native. But few data historians are cloud native right now. Okay, so that's something bad on the for the data historians. But look at the world. Our business needs are changed. First thing I would like to say, traditional data historian works very well for a single site, but now there is a demand to centralize data from multiple sites. And if you have multiple sites, the data historian vendor may be different. For one side, people may use Pi system. Another side they may use Wonderware. But you do want to centralize data from both sides, then the system are different. You need a solution to centralize data from Pi, from Wonderware, from AspenTech, right? And also the technology are, of course, are different too, okay? So there's some challenges. Another thing is once your data centralized, you want to enable advanced analytics to get the global view for your data. For the advanced analytics, now, it's AI age. You even want to apply your own AI algorithms for maintenance prediction or anomaly detection. So not only your house build, home build analytical tools, you even want to drag third-party analytics tools to do some analysis on your data. So third thing is everybody want to share the data. Once the data is centralized, you want to share the data with the internal stakeholders or external stakeholders. Because everybody want to utilize the data to get the result. For example, for a connected vehicle, the T box, okay, connect so many data from battery system, from motor system, from even the user behaviors are connected. But now many external stakeholders want to get the data. For example, the battery vendors want to get the battery data. Motor company want to get the motor data. Everybody want to get their own data, okay? So you need a very good system to share the data. The last thing I already talked about that is number of types is increasing exponentially. We need a new pricing model. If you still keep the old pricing model, charging customer based on the number of types, it's not acceptable. If you have 1 million or even 10 million tigers, okay, how much you are going to pay? Too much. So we need a new price model. So when you think about those new business needs, I think we need a new generation data historian. Actually, TDengine is kind of a new generation data historian. So today I'm going to talk about more about what we are doing, what's new for the next generation data historian. Okay, so I founded the TDengine almost 6 years ago. It's the core for TDengine is a time series database, but we treat it as a next generation data historian. There are 4 major features, okay, for our product or our cloud service. The first feature is data centralization. Okay, it can centralize data from different systems, like from Pi, from OPC, from MQTT brokers. I'll talk about more on data centralization part. Once the data is centralized, TDengine can provide the very good, efficient storage for those data. And also, of course, it provides modern analytics. And also, it can distribute the data to internal or external stakeholders. Okay, so there are 4 major features. First one is for data centralization. Second one is it provides storage. It's a kind of database. It's a time series database. Okay, third one, it provides modern analytics. Fourth one is it has very good data distribution. Okay, so let me talk about more about the data centralization. For data centralization, it requires a very good data ingestion. It can ingest the data from data sources like a Pi system, MQTT, OPC UA, or OPC DA. You even have a connected to Wonderware. Okay, once the data is ingested, we need to guarantee the data quality. So it has the cleaning and transformation tools built. So TDengine provides cleaning and transformation features to guarantee the data quality. You can define your own rules to clean your data, to transform your data. So the data can be written into storage with a very good quality. And also, you need to guarantee your data integrity because the network may be interrupted, right? So you need a backfill in the event of service interruption to guarantee you have very good data, to guarantee the data integrity. Number 4, for data centralization, you need a very good management for your data sources. The data sources can be added, removed, reconfigured, and monitored, right? So because you may have multiple data sources, okay, you may remove the one data source, and also maybe you need to reconfigure the data resource, and also you need to know what's going on for each data source. Later on, I'll show you the demo, how to add the data source, how to remove, how to reconfigure, and how to monitor the data sources. Okay, I'll run the demo later. Okay, that's for data centralization. Of course, once data centralized, we need a very good data storage. Okay, our data storage is based on our open source software, the open source time series database TDengine. Okay, it's based on our open source. And our open source time series database has a very good performance in terms of data ingestion rate, query latency, and data compression. How good it is, I'm going to talk about it later in another slide. And also, because the IoT data volume is huge, okay, so many devices are connected, so it generates tons of data. To reduce the cost, we have a very good feature. It's called tiered storage. Data is automatically transferred to different storage media based on time range. For example, for the warm data, it's saved in SSD. For cold data, it's saved in local drive. For like very cold data, it can be saved in S3 on Amazon. Okay, so your cost can be reduced. Okay, so we have a very good feature for tiered storage. Now, another feature, where once your data is stored, of course, you need to get some value from those data. So you need a very good analytics or visualization tools to help you. TDengine support standard SQL, but with some time series extensions. I'll talk about the time series extensions later, okay, in another slide. Besides SQL support, TDengine also provides stream precision for real-time analytics. So there are some background tasks running to provide you real-time analytics. And also, TDengine supports listed queries. So you can run very complex queries to get a result. For example, you can group by, order by the query result. Okay, and also besides the functions we provide, you can define your own functions, okay, by Python or by C. So if you can't find the functions in our documentation, you can have your own defined functions. That's a very good feature. Another good feature is we combine historical and real-time data analysis together. We don't divide data into historical data or real-time data. So it's a unified analysis. So it's more convenient. TDengine is an open ecosystem. Like only other modern software. Okay. The good thing for open ecosystem is you can integrate TDengine with many third-party tools like Grafana, okay, like Seek, like Trained Miner, okay, through JDBC or ODBC interfaces, okay. And of course, now we live in the AI age. There's so many AI analytical tools on the market. For example, Uptime. This is a tool. It's called Uptime. Yeah, some like chemical engineering. Some people use those tools. You can integrate Uptime, this AI tool, with our TDengine. So many AI tools on the market. If you use traditional data historian, it's very hard to integrate those modern analytical tools with them. But for TDengine and any other modern software, they don't, you won't have any problem to integrate like a modern visualization tool or analytic tools. For example, you can even integrate Power BI or Tableau with TDengine very easily. Okay, another this slide I'm going to talk about the time series extensions because we support SQL. SQL is very powerful query language, but for standard SQL, they don't have a good functions for time series and analysis. We provide very good time series extensions. For example, accumulated sum, moving average, time weighted average, derivative, and even you want to do interpolation if you don't have data points at a specific time stamp. Okay, and also we provide all kinds of windows like a session window. For example, you start something, then you stop your car, start your car, then you stop your car. That's a session. You can apply your analysis on this session. You can have a state window. For example, the state is on or off. You can analyze those data in specific state. You are, of course, you can have a sliding window of, like, for example, you can build your dashboard. The dashboard can be flashed every 1 second, right? So you can watch the trends in real time. That you should use sliding window to build your dashboard. And very good thing is like for PySystem is event window. TDengine also supports event window. The event can be defined by specific condition. Okay, even the start event is different from stop event. Okay, you can define based on your own rules, and there's so many more. You can check out documentation to find more how to use those time series extensions. It's very helpful. Okay, useful. Now I also want to talk about very good thing about the data distribution or sharing. Okay, because as I explained it to you before, once data is centralized, many parties want to get your data. Okay, but you only want to share the data you want to share. You don't want to share more, or you don't want to share less, right? So you have to control the data granularity or for the data you want to share. Okay, for example, for your internal team, you want to share the whole in the entire database. But for some people, you want to share a table or a subset or a set of tables, not all those tables. Or sometimes you just want to share a set of columns. For example, you have like 100 columns, but you just want to share 10 columns, okay, with your partners. Okay, you don't want to share all those columns. Or sometimes you even just want to share aggregated data, not the raw data. For example, I just want to share the average like a temperature every 10 minutes. I don't want to share my raw data like a raw temperature. I just want to share my average temperature for every 10 minutes. Okay, so that's aggregated results. I don't want to share my raw data. So that's can be controllable. In TDengine, it's just defined by a SQL. You use SQL to control what you want to share. Okay, so it's very flexible. Okay, and also you can configure expiration date. And also, of course, the system will generate a secured token for you automatically. So if for the expiration date, it's very convenient too. So for example, I just want to share the data with a partner for 1 single day. Or after 1 single day, the sharing will be closed automatically. So you don't have a data security problem. And also, once the data is shared, you share the data with a partner. It's just like a share with a Google Doc. It will generate the sample code for you automatically. You just need to copy and paste your sample code. to then you know how to consume the data. It's very easy to use. Okay. Now on the market, TDengine is just one of the next generation data historians, right? But what's the competitive advantage for TDengine? Okay, I'll talk about that. First one is TDengine has a very good performance in terms of data ingestion, query latency, and data compression ratio. Okay, based on the benchmark report, TSBS, for time series data, there is a popular benchmark testing report. There is a popular time series data benchmark report. It's called the TSBS. Okay, based on this report, our TDengine can beat like InfluxDB or timescale DB a lot. Like for data ingestion, TDengine is like at least 2 times fast than InfluxDB or timescale DB. In some cases, it's even 5 times fast for data ingestions. For querying, it's like at least 1.5 times fast. For some cases, it's even 33 times fast. Okay, in most of the cases, TDengine is much fast compared with InfluxDB or timescale DB. InfluxDB and timescale DB are also open source, just like TDengine. Okay, look at this slide. It's a disk space. Okay, TDengine also outperforms InfluxDB and timescale DB. Even compared with timescale DB, maybe just 1/10 of the disk usage. Okay, another slide on this page is like a CPU usage for the system resources. TDengine requires much less system resources. Okay, even it has much higher performance. All you guys are welcome to check out our benchmark report on our website. You can download. And the very good thing for our benchmark report is you can try by yourself. We have a script. You can download a script to run the benchmark report by yourself to see if our to generate the report automatically for you. Okay, that's one good thing for our product is performance. Another thing is TDengine is built to scale. The whole architecture is a distributed architecture. Today, I don't have enough time to talk about our architecture. I will just give you a brief introduction. You can have many nodes in the system. For example, on this PPT, we have 6 nodes, right? Each node can contain multiple shards. It's called V nodes, like V2, V7, V6. And for each V node or each shard, there may be multiple replications to provide data, to provide high availability. So in case one shard is down, the other 2 windows are still working, then the system is still working. You can still write data or query data. So the system has TDengine provides high availability. Okay. Besides the V nodes, we also have management nodes. Every node report the status to management nodes. So the management nodes can decide the load balance. Okay, can decide how to allocate the system resources. Okay. Besides the M node, we also have a specific node. It's called Q node, query node. Because TDengine is designed with a philosophy, compute is separated from storage. Okay, if you have a query, it requires lots of computing power. Q node can be stopped dynamically. Once your query is done, Q node can be stopped to release computing power. So it's elastic. Okay. So TDengine is a cloud native solution. Okay. Of course, the whole system is very complicated, but TDengine provides a driver. This driver had all those details from application. From application point of view, the whole system is just one single device. You don't know how many nodes in the whole system. You don't know there are 6 nodes. Looks like one single database, but actually there are 6 nodes. There are many V nodes and Q nodes inside. So our client TOC had the details. Okay, that's our distributed architecture. And also, TDengine solves the high cardinality issue. Okay, for example, for the big data, you have a big pile of data, but TDengine divides the data into 2 dimensions. Okay, one dimension, they partition the data by 10 dimensions. For example, the data is every file can contain data for only 1 week. Another file contains data for another week. Okay, another week. And also, on another dimension, we divide the data into based on the devices. For example, this V2, node 2, contain data from 1,000 devices. Another V3 contains data from another 1,000 devices. Okay, so we divide and conquer the data from 2 dimensions. One dimension is 10 dimension, another dimension is devices. Okay, and also I want to mention every node, every V node contains the metadata. Okay, so even our metadata is a distributed design. With this distributed design, the whole system can support over 1 billion time series. So I can tell you, TDengine very scalable, is a scalable system. It can support 1 billion tigers. Okay, without the only performance issue. That's one big competitive advantage. Another big advantage is big data without big cost. Okay, even it has very good performance, it's very scalable. It doesn't mean you need the cost is that high. First of all, we have a predictable pricing. We don't charge based on number of tags or time series. We charge based on the size or on resources, on the computer and storage resources, not based on number of tags. Just like virtual machines, like for each core, you can check our cloud service price on website. I'll show you later. It's fixed as charge. Okay, on-prem is based on number of cores. On cloud service, compute and storage build separately. Okay, and no only upfront cost is built hourly. Okay, no decision plan. Okay, so our pricing model is totally different from traditional data history. And also, for TDengine, it's not just a time series database. It's a simplified solution for the time series data. Okay. Besides the time series database, it has built-in caching, data subscription, stream precision. It also even has built-in ETL, extract, transformation loading. I already explained this. So with this simplified solution, TDengine can reduce system complexity, and it can reduce operation cost a lot. Right? Look at the risk diagram. In the old design, you need 5 components. You need Kafka, ETL, Redis, database, Spark in your system. Now you just need the TDengine. Of course, your operation cost will be reduced. Okay, so we support the bigger data, but without bigger costs. Okay, and also another thing is tiered storage. I already explained. But this slide explained the tiered storage very well. For example, the hard data is saved in memory. Warm data is saved in SSD for just 10 days. Cold data is saved in local hard drive, and the frozen data is saved in S3. Okay, right? So data is automatically transferred to different storage media based on time range. you can configure how long you want to keep the data on SSD. You can configure how long you want to save the data in local hard drive. Okay, it's configurable. Another thing is, unlike many traditional data historian, TDengine is very easy to access. You can start TDengine in just 60 seconds. Why? Because it supports standard SQL. As long as you know how to write SQL, you can use TDengine right away. And also, we have a zero-code integration with a variety of industry data sources. For example, it has connected for PySystem, it has connected for OPC, it has connected for MQTT. You just need to config. You don't need to write a line of code. Okay, it's very easy to start. I'll show you later. And also, we have connectors, command libraries for all the popular programming languages, such as Python, Java, Go, Rust. Okay, and also we have open source version. You can download. You can go to GitHub, download source code to build by yourself, or you can download our package from a website right away. It's very small. Okay, another very good, beautiful thing is we have a cloud service. It's free. You can try 1 month free. Okay, so we claim you can start TDengine in just 60 seconds. Later on, I will run the demo to show you how quick I can set up everything. So by this way, everybody, I think, want to do digital transformation. Digital transformation much easier than ever before. Okay. And of course, I already mentioned the TDengine Cloud. It's a fully managed service. It can be run on AWS, Microsoft Azure, or Google Cloud. Okay, and also we build storage and computing separately. And for cloud, we provide a feature. You can replicate your data to other instances and even other clouds and regions with just a few clicks. So you don't need to worry about your data loss. You can always do real-time data replication from one cloud to another cloud, from your public cloud to private cloud. Okay, and of course it's enterprise ready. So we have a backup. We support VPC peering. We have IP whitelist, so to guarantee your data is really secured. Okay. Another very good thing for TDengine is TDengine core is fully open sourced. Okay, we open sourced TDengine 4 years ago. Last year, we even open sourced cloud native solution. 3 years back, we open sourced the cluster edition. InfluxDB is also open source software, but they don't open source the cluster edition. But TDengine open source the cluster edition. Up to now, we already have over 21,000 stars. And every day, at least 500 new instances are running in the world. Up to now, over 350,000 running instances in over 50 countries. I'm very proud of those numbers. So many people in the whole world are using TDengine. Okay. And now this slide, I just want to give a brief comparison between new data historian with the traditional data historian, right? So for TDengine, for like a next generation data historian, it's a distributed design. But for traditional data historian, it's a monolithic design that it cannot scale easily, right? For next generation data historian, is an open ecosystem. For seamless integration is a third-party tools. But for traditional data historian, it's a closed ecosystem. They always want to lock the user into proprietary software. Okay, for next generation data historian is affordable pricing based on computer resources. But traditional data historian, they always want to charge based on number of tags. Okay, and the next generation data historian can be deployed on public, private, or hybrid cloud scenarios. But for traditional data historian, can only support on-prem deployment on Windows machine. Even they cannot deploy on Linux. Okay. Now I want to give you one case study. You guys can find more cases on website. This one is for like power plants. One of our customers in New Jersey, they have more than 20 power plants. They have multiple sites. Each site has it's running with a Pi system. Okay, but they want to get a global view for the system. So they dump the data from each Pi system into a CSV file. They connect those CSV file onto the cloud. Then they use the CSV file to build the dashboard. It's really not convenient. They also want to try like a Pi system. Aviva also has a service. It's called Aviva Data Hub. But they think they want to use Aviva Data Hub, but they think Aviva Data Hub is too expensive. So they switch to our TDengine cloud service. So inside each site, they install a Pi connector. So then centralize the data into our TDengine cloud. And they use Grafana to build an open source visualization tool to build their dashboard. They don't use process book. Okay, inside each plant, they still use a process book, but on cloud, they just use Grafana to build the dashboard. So now it's running very well. For they use our TDengine cloud to manage their like almost 30 power plants. Okay, they saved lots of money. Okay, and also the dashboard is much beautiful than process book. Okay, now let me take some time to give you guys a demo. Okay, almost 40 minutes. I want to show you how to run. Let me go to my website. Okay, that's our TDengine. Okay, our website. Go to our website. It's slow. Something. You can check like Industrial 4.0 with TDengine, next generation data historian. It has some brief introduction for what I'm talking, like a high performance. You can download our benchmark report. You can look at our blogs to see check our distributed architecture design. So many things. Okay, now let's go to our cloud. Okay, I'll just run a quick demo. Okay, now I'll just use my email to go to your cloud. I'll just give you a demo. I'll just register my account right now. jhtao@tdengine.com. Now let me send an email, get my confirmation code. Let me check my email. Okay. Hold on. Sorry, a little bit slow. Okay, I got my confirmation code. Let me type in 168 983. Okay, sign up. Now I'm in. Let me set password. Okay. Now the system, I just set my password. I'm doing registration. Here, once you're registered, TDengine provides some sample databases in the system. because when you register our cloud service, you want to explore our features. Then you need some sample database. Here, I want to pick up this sample database. It has 10 billion rows of data points from smart meters, from 100,000 smart meters. Let me click this sample database. Okay, now let me click next. Okay, I want to create an organization. How about TD demo? That's an organization. If you need a single sign-on, you can enable single sign-on. Now I create an organization successfully. Now I want to create a instance. How about Jeff Wang? Now I want to select a price plan. I will just pick up the starter of $800 a month. Then I'll create the instance. Let's see. Now I choose the AWS. One instance will be created on AWS for me automatically. Okay. When you register cloud service, you will get 1 month free, or actually $820 credit. So you can use this service for 1 month free. Now it's starting. Now ready to go. Okay. Now it's ready. Now everything is ready. You can allow, there's some tutorials. It gives you some introduction about what is TDengine, some concept. You can take time to learn. Okay, everything is ready. Now let me just show some demos. Now that's the dashboard. For example, the data in. You can in the data in, it's a little bit slow. I don't know. You can click add config. Like for example, you have OPC. How? Okay. You can configure the data type to be OPC. Then you can configure the parameter first for each OPC connector, and also maybe you can choose Pi system. Okay. Even for Pi system, the same. If the Pi system is set inside your private network, you need to create a new agent. But if it's in the same system, you don't need an agent. Okay. You can even migrate the data from InfluxDB to TDengine Cloud. You can even configure MQTT as a one-way data source. Okay. Then you don't need to write a line of code. You just need to follow the instructions on this phone to create your own data source. Okay. On Explorer, you can write your own SQL commands. For programming, we support like Java, Go, Rust, Python. We even support R. For each programming, we provide the sample code. You can just copy and paste. It's running. Here, you can configure your string. The string can be running in the background. Here, if you want to share the data, you want to create your topic. For example, create a topic. I want to give a demo, a topic from my test database, from my soup table. Then I create a topic. You can share this topic with others. Here, like for example, you can share. Okay. And also it generates the sample code for the topic. You can just copy and paste the code. It works. Okay. In this type, you can, for example, you can use Grafana or you can use Google Data Studio to visualize the data. There's so many features. Okay. But now I just wanted to run a quick demo for how fast it is. Okay. Just now, here, let me check. I just enabled a sample database, public database. It contains 10 billion rows of data points. Okay, this database contains 10 billion rows of data points from 100,000 smart meters for nearly 3 years. Each smart meter connects the current, voltage, and phase every 50 minutes, and it has 2 static attributes: location and group ID. The raw data size is approximately 200 gigabytes. Okay, now let me run some queries. Okay, I already have some favorites. For example, this one. Okay, no, actually, I want to run this one. Let me run. I want to run. I want to run this. I want to find out how many number of rows. I want to find out the max value for the current. And I want to find the average for the voltage, okay, from VOL. From all those smart meters, from 10 billion rows of data to check. Now, you already got a return. How quick, right? Check the log. It takes like 1,000 like 1.3 seconds to get the result. Let me run again. Yeah. It takes 1.2 seconds to get the number of counts and max and average from 10 billion rows of data. Think about this database contains 10 billion rows of data. Okay, if I just want to get the data from one specific devices, how about that? It will be very, very quick. This is a specific smart meter to check, like it only contains 57 milliseconds. Okay, and also this time contains network latency. If now I'm sitting in my network connection is not good. If my network connection is very good, definitely it's less than 1 second. Okay, you can run all kinds of queries. We already put lots of commands here. Okay, you can try. You can write your own SQL commands. If today I have enough time, I can show you all kinds of SQL commands. Okay, I hope you can register our cloud service. You can explore. You can try by yourself. Okay, we have multiple databases, sample databases. Okay, another one that's for the truck. Okay, real-time ship movement in 5 US ports. Okay, another one is for air quality database. We have 4 sample databases in our cloud service. All you guys can try. Okay, now that's my demo. Let me go back. Okay, I think that's for my demo. That's my presentation today. I want to leave some time for questions. Before I go to questions, I hope everybody can follow me on Twitter, follow me on LinkedIn. That's all my contact information. Because although I'm the CEO, but I'm the developer. Actually, I developed the first version of TDengine by myself. Okay, at my home. Okay, so if you are engineer, you are developer, I really like to talk to you. If you have really technical questions, I'm the best person to answer. You can ask me questions from LinkedIn or Twitter, or send me email, or join our Discord channel. Okay, okay. Thanks a lot. Yeah.
Thank you, Jeff. That was an insightful presentation and case study, and thank you very much for the demo. So we'll get into the Q&A now. A reminder for our audience to submit questions using the Q&A tab in the webinar platform. I think we have one question, at least to begin with. The question is there an API for Microsoft.NET Core and or .NET Framework?
Oh, yes, of course. We support C#. We support Microsoft.NET. We have a client library for C# for Microsoft.NET. Yes. Okay. Why I can't find the questions?
So what kind of data infrastructure is required to support AI-based solutions in the near future?
Actually, very easy, right? Our TDengine is already ready to support AI-enabled analytics because it's an open ecosystem. It can be integrated with only other third-party tools because it has standard JDBC, ODBC driver. So only third-party tools which can support JDBC and ODBC can be integrated with TDengine. So as long as your AI analytic tools support JDBC, there is no only problem.
Fantastic. And another question here is, how would a centralized data platform deal with different tags or timestamp intervals at different sites?
Oh, very good question. So if you check TDengine documentation or design, we have a very specific command. It's called interval. It can align the timestamp. Okay. For example, every device has different sampling rate, sampling period. So with this specific command interval, actually it's a kind of a period. It can align timestamp from each devices. Then you can apply your analytics on those data.
Well,
Any more questions?
There are no more questions at this time. Anybody who wants to ask a question, remind us this Q&A on the right-hand side of your screen. And if there are no more questions, then Jeff, I think, given that you have given folks an open channel to reach out to you, and I hope they do. Thank you very much. I want to thank you all for joining us and your insightful questions. Feel free to reach out to Jeff, and thank you to our presenter again, Jeff Tao, for sharing your time with us, and thank you again to our sponsor, TDengine. We hope everyone enjoyed today's webinar.